Shalom to you and welcome. This video we will use distance and midpoint formulas to solve problems. Okay, those are our objectives. So talking about distance, the coordinate plane x and y are the basic major plane we know and we use a lot in mathematics. So we need to identify the distance again. The distance is the absolute value, which is how far a number is from zero. But we're going to look at a distance not only from zero, but we need to understand that basic of the distance of the absolute value. So here, demonstrating the like point, every point kind of make that reference from 0. 0.32, think about the x value of it. It's 3 units away from y axis. It's 3 units away from y axis and it's 2 units away from x axis. So that the vertical distance change is the y, the horizontal distance is x. Okay, so let me start up. So the same thing, distance cannot be zero. Distance cannot be negative. So we refer to the distance. If it goes down here, 3 and negative 2 will be the same distance because it's going to be 2 and 3. 2 vertical, 3 horizontal. The same thing as 3, 2. Okay. So, but when it gets to the other side, you see the 1, negative 3 comma 1 is 3 units, is 3 is horizontal, which is x. That is always for x, and vertical is always for y. So 1. Okay. So and then we can identify the signs, whether it's positive or negative. We always start from the x-axis, and then we go counterclockwise direction. In the first, to count our quadrant, in the first quadrant, we say x is greater than 0, y is greater than 0. That means that x is positive and y is positive. And then in quadrant 2, x is less than 0 because x is negative here. So x is negative and y is positive. In quadrant 3, both of them are negative. And in quadrant 4, x is positive and y is negative. So anything below x-axis, y is negative below x-axis and y is positive above the x-axis. X is positive on the right side of the y, which is in quadrant 1 and 4, and x is negative on the left side of y, which is quadrant 2 and 4. So keep those in mind. Can identify which quadrant a number is looking at their sign. Again, if we look at here, we have where x is positive. You can always just make, draw a little quadrant there. We have positive, positive, negative, positive. Okay, that helps in the order. Negative, negative, and positive, negative. So you can see negative, positive would be quadrant 2. Negative, negative, quadrant 3. So once you draw something like that, it's easy to just see. So positive, negative, that will be quadrant 4. Okay. Now, finding distance between 2 points, again, when it doesn't start from 0 anymore. So, but we can create a triangle, a right triangle, and then using Pythagorean theorem, we can find the distance, this distance of the slanting one. The vertical and horizontal distances can help us find the slanting distances. So whether you drew it down this way or up this way, it's going to be the same thing. Going from this point to this point, whether you go horizontal and go vertical, or you go vertical up and go horizontal, you still get to the same point. the same distance. So if we find the vertical distance from there to there, we see that the x value is the same on both, and then y value is the same on the down here 3 3. So you subtract the y value, 6 minus 3, that gives us 3. Subtract the x value, x changes on the horizontal, so 5 minus 1, that's 4. So, and if we use Pythagorean theorem, because this forms a right triangle, d square equals 4 square plus 3 square. So that's where the distance formula comes from. So let's derive it technically. If we have a right triangle, have a point someplace safe. So finding the distance between these 2 points, point A, point B, point C. So if we have, so if we represent this point here with, this is x1, y1, and then here we have x2, y2, and so under here they will have the same x value, so it will be x2 2, and it will have the same y value with this one, so that will be y1. Now to find the distance between these, this whole length, it's going to be the vertical, the distance of the vertical. So we're going to subtract y2 minus y1. So it's the absolute value, because distance cannot be negative, so we keep the absolute value here. So we do the same thing for the distance from here to here. That's going to be the absolute value of the y, the x values. So x2 minus x1. Okay, so using Pythagorean theorem, if this is the distance, so we can name this point 1, and this is point 2. So the distance of point 1 from point 1 to point 2 is, with the Pythagorean theorem, the square root of Pythagorean theorem is always like d squared. So instead of taking this, to remove the square, we take the square root. So the length x2 minus x1 minus x1 squared plus y2 minus y1 squared. So watch here that the plus is in between the y and x, but the subtraction, which is the distance, subtraction distance is always the subtraction between the x's and between the y's. So that's the distance formula. Again, this is just saying the distance between point P1 and point P2. Just technically. So here, that's what we just derived. So let's use it to solve problem. Do these points form a right triangle? Well, how can we tell? We have to find a triangle. Let's locate these points. First, if we draw the coordinates, so this is y, this is x, where would they fall in? Point A is going to be, point A is going to be negative 2, 1. So let's say negative 2 is somewhere here, negative 2, 1. And so this is like point A somewhere there. And then point B is positive 2, 3. Positive 2, 3 will be about here. Positive 2, 3 will go up. So point B positive 2, 3. Then point C is 3, 1. So 2 is here, so 3 will be a little further, and then 1, this is 1, so it's going to be on the same with 1 here, but a little further on the side of 2, 2. So alright, so this is point C, and 8, 3, 1. So these points, well, we're going to find their distance first, their length, the length of the sides of this triangle, and then decide which side is longest, and then use Pythagorean theorem to see if they respect the Pythagorean theorem. If they do, then that it will be a right triangle. So let's find B. Number 1, we find this is A. So let's find AB. So AB, which is the distance between point AB, equals, so the square root of, so if we take this, subtract the x's, 2 minus negative 2, 2 minus negative 2 squared, plus 3 minus 1 squared. Okay, so that will be 2 minus negative 2 will be the same thing as 2 plus 2, because when you subtract an integer, you add its opposite. So 2 plus 2 is 4, it's 4 squared, plus 3 minus 1 is 2 squared. So AB is 4 squared is 16, 2 squared is 4, so AB equals 16 plus 4 is 20. So we can leave it like this. Let's not worry about simplifying it until we find all the sides. And then AB, let's say A or BC is the square root of, so BC, so we do C, 3 minus 2 for x, plus then the y, 1 minus 3. Again, do not think that, oh, 3 is bigger, so you have to do 3 minus 1. Remember, you have to go in the order. Since we started with C first in the axis, we have to start with C for y also. You have to go in that order. So BC equals 3 minus 2 is 1 squared, plus 3 minus that is negative 2 squared. So BC equals 1 squared is 1, plus 2 squared, negative 2 squared is 4. So the square in negative makes it positive, so square root of 5. Again, we leave it like this for now, and then we find the last one. We're gonna find the distance. So this one is square root of 20. This is square root of 5. Okay, let's find AC. AC is the square root of, so we have AC. So we can do 3 minus negative 2. So 3 minus negative 2 squared, plus 1 minus 1 squared. So AC equals, again, 3 minus negative 2 is 3 plus 2, which is 5 squared, plus 1 minus 1 is 0, 0 squared. So AC is simply 5 squared is 25 plus 0. So this is square root of 25. Okay, so if we apply the Pythagorean theorem, and we can see square root of 25 is biggest, so that would be the hypotenuse if it is a right triangle. So the hypotenuse squared first. So that's the hypotenuse squared equals leg squared. That's the Pythagorean theorem. So the hypotenuse squared equals leg 1 squared plus leg 2 squared. So square root of 25 squared, does it equal square root of 20 squared plus square root of 5 squared? Well, if we squaring will remove the square root, so we just have 25 equals 20 plus 5. So 20 plus 5 is 25. 25 does equal 25. So yes, it is. So there's a right triangle and the hypotenuse is 25. So this is a right triangle. The points form a right triangle. Good problem. Okay, midpoint. Okay, midpoint now. It's the median of the segment, any segment at all between the 2 points. So watch, in the distance we subtracted the 2 x's and the 2 y's, but in here we are adding them. Do not confuse. Make sure you understand the concept that it is almost like when you find the median of 2 numbers, you're just finding the average of that 2 numbers. So the average of the 2 x's and the average of the 2 y's. So that's why you add them and you divide by 2, because when you find average, you add and divide by how many numbers there are, since they are just 2 numbers. So the median drawn from a vertex of a triangle down to the side opposite it bisects the side. So we'll just use that median between point, the halfway of the x and the halfway of the y's. So this is ordered pair. So the midpoint of the line segment from point P1 to P2, they gave us the midpoint, so they want us to find so let's define them. So the midpoint is 5, -4. That means that this is for light green. That this is for the midpoint of x, and this is the midpoint of y. Okay, so it's good to define things so you don't put the right thing in the wrong place. So, and then we are giving point 2 to be 7, comma -2. That means, okay, let's wait. And then we are looking for point 1, which will be our x1, y1. We don't know. So this is our x2, y2, since this is point 2. Okay, so if we look at the formula for the midpoint of x and y is x1 plus x2 divided by 2, comma xy1 plus y2 divided by 2. So we're just going to use this formula to substitute. For x, we just use it to find the value for x here, and then we use y1 y2 divided by 2 to find the y there. So let's separate them. Okay, so we do the midpoint for x is going to be x1 plus x2 divided by 2. And then the midpoint for y is going to be y1 plus y2 divided by 2. Okay, so those are the two ordered pair, because then we replace the mx, which is the 5 here, that is given for the midpoint. So 5 equals, so x1 we don't have, we're looking for. x2 is 7, we do have, so over 2. So now we do the algebra. So we can multiply this side by 2 and multiply this side by 2. So that gives us 10 equals x plus 7. And now we can subtract 7 from both sides. So 3 equals x. x1, sorry, this is x1. So, yeah, so we have x1 equals 3. So because we're looking for p1 here. So we're going to do the same thing for y. So y, midpoint for y is negative 4. So substitute negative 4 equals y1 plus, and again y2 is negative 2. Okay, and then we again multiply by 2, multiply by 2. That will give us negative 8 equals y1. Okay, so y1 plus negative 2. Now we add 2 to both sides. So that gives us negative 6 equals y1. Okay, so now we put that in here, negative 6. So that's our, we have found the point P. And we can check it. We can check it by finding the midpoint, adding those two, see if we get the same thing. So I'll use purple. So the midpoint of x, y is, we add the x1 plus x2 divided by 2, y1 plus y2 divided by 2. So here, again, x1 now, we have a 3. So that will be 3 plus x2 7 divided by 2. And negative 6 plus negative 2 divided by 2. So if we simplify those, that should give us, that's 5. 10 divided by 2 is 5. And negative 6 plus that is negative 8. Negative 8 divided by 2 is negative 4. So that checks our answer, the original thing we are given. So that's correct. Okay, and yeah, so with that, what we just checked here, how to find midpoint. So that, I hope that kind of, with that we went around, if you're given 2 points, how you can find midpoint, and then we already did, if you're given one of the points, how do you, and the midpoint, how do you find the other. Okay, so that helps. That should be enough for now. Thank you.